Hey guys, welcome back. For today's video tutorial, I'm gonna work on a new sensor that is MMA7455. We have been working on different sensors, digital sensors, and this is a new sensor which we're gonna work today. And to gain more knowledge about this sensor, let's have a look over this sensor. For that, we have to log on to the website www.controleverything.com, and here we have to search for this particular sensor that you can see. And here let's have a look over that and see what we got for this particular sensor. And we got that MMA7455 is a 3-axis low gravitational digital output accelerometer. As you can see, these are some of its features, and please have a look over that. And you can also purchase this sensor from here. I'm going to show you the working of the sensor MMA7455 with a Raspberry Pi and a Java code. And to get the Java code, let's have a look over the resource tab, and here is our Java code sample. Now you can download the Java code sample as a zip file from here, just like this, and you can also have the code from github.com, and the repository there is Control Everything Community. Now we require to assemble some of the hardwares along with the Raspberry Pi and the sensor so that we can have this video a success. So for that, let's make some connections. Now this here is our sensor, that is 3-axis digital output accelerometer MMA7455. Now what we require is this, a Raspberry Pi. Now these are the GPIO pins of our Raspberry Pi. Now the problem is to make a connection among the sensor and the Raspberry Pi and make this connection with other I2C devices also, and make the connection a lot easier along with the probable factor. So what we require is an I2C shield. So make this connection and gently place over the I2C shield over the GPIO pins of the Raspberry Pi. As a matter of fact, this I2C shield also available on the website controleverything.com. Now we want to make a connection among the sensor and the I2C shield, and here comes the connecting cable. Now make this connection, and while making the connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this rule for I2C shield also. Now we need to power up our Raspberry Pi, and here comes a micro USB cable into the picture. Now gently process it over the power jack and gently insert it there and light it up. So we are done with this connection. Finally we have to make an internet connection, and we have two ways to make that. First, this is an Ethernet cable, as you can see on my screen. Now gently insert it over the Ethernet jack. In case if you don't have this, you can also have the opportunity to use a wireless nano adapter for Wi-Fi connection, and this might save your day also. So we are done with the hardware connections we require for the interfacing. Let's have a look over the code. Now our next step is to interface the sensor with the Java code, and for that we have to log into github.com, and here search for the repository, the official repository of controleverything.com, that is Control Everything Community, which you are able to see on my screen. Now get over it, and here search for the sensor MMA7455, and here we get our sensor, and this is the Java code we will like to explore. But before that, let's have a look over the instructions. First, we have to download and install the Pi4j library on the Raspberry Pi, and the steps are being provided on this very link, pi4j.com. So why not we have a look over this link. As you can see, all the prerequisites, installation methods, commands, offline, online, everything is being provided on this link. Please go through it carefully. Now this is the command to compile, and this is to run the Java code. Please note it down. Now get back to the Java code, and here we go. It's a .java extension file, as you can see. Now we have to import some of the libraries, as you can see on my screen, which have some functionalities which we will use later in this code. And we have created a public class named MMA7455. Now here we have the bus.getDevice 0x1d is the address of the sensor. Now for the writing part, to give commands to the sensor for working, we have selected control mode register, and measurement mode is ±8G. Writing command, as you can see on here. Now 0x16 is the select mode control register, 0x01 is the command for measurement mode. Now we are done with this part, as we have delay, so that the sensor can a comment to what the command is being given to it. Now we have to read 6 bytes of data. Now the data is being written from 0x00, and this is the conversion part of the data along with that, as you can see, which is according to the data sheet of MMA7455. At the very end of our output data, we have to display the code. So for the results, acceleration in X, Y, Z axis, we have formatted into raw values, %d, perfectly. Now this is the code we have to follow through. Now for the working, let's have a look over it. Now here comes the interesting part for the video, that is the practicality of this code. So copy this entire Java code and open up the terminal for the Raspberry Pi. Here create a new file. .java is the extension, as you can see. Paste the entire code, save it, and this is the command to compile, as you can see on my screen, and the code is being compiled. It might take a while. It's done. Now this is the command to run the code. So here we go, as you can see, acceleration in X, Y and Z axis. Again we have the same data, almost stable. Now when I try to rotate it and run the command, you can see change in the values for X, Y and Z axis in acceleration data. So as I continue rotating the sensor, command will be there and the changes are being monitored on the screen. So this is how the Java code works with the sensor. So now let's have a look over the applications and the benefits for the sensor MMA7455. So we are done with the working of the sensor MMA7455. Let me tell you, MMA7455L is a digital output, low power, low profile, capacitive, micro machined accelerometer featuring signal conditioning, a low pass filter, temperature compensation, self-test, configurable to detect 0G through interrupt pins, and a pulse detect for quick motion detection. So these features make it very important for a lot of applications like cell phone, PMP, PDA, image stability, text scroll, freefall detection, pedometer, motion sensing, and a lot more. This sensor can be purchased from the website controleverything.com, and the relevant code is also available on the same site. You go to resource tab and here comes the sensor code. Now you can also get the code from GitHub repository, that is Control Everything community. So at the end of this, I just want to make it clear that in case of any further queries regarding any part of this sensor or any video part, you can contact me on controleverything.com and you can post your comments on the community page of this website. Now for articles and blogs which are relevant to this video, you can have a go through look over instructables.com, and to subscribe more video tutorials which are coming through, and for this video tutorial you can also subscribe onto our YouTube channel. So at the very end of this, I hope you enjoyed this video and yourself have a good one. Thanks a lot for watching.